Thank you, everyone. Look, I'm really excited to be able to finally talk to the RGSQ audience and everybody else who's come along as well. So yes, I'll be talking about the Queensland Earth Observation Hub, and we can make it a little bit interactive. Anybody want to guess what the satellite seed is? So that's Cairns.
Oh,
Yeah.
Yeah, and that's I think that's Yorkeys Knob, where my sister lives. So.
I thought you were talking about what was sent on the web.
Right. Okay. Okay. So a little bit about me. I am the spatial sector lead for Frontier SI. It's very hard to read my speaker notes here, so I can move things around a bit. Frontier SI is a social enterprise dedicated to solving complex challenges using spatial expertise. And I am also on subcontract from Frontier SI, the coordinator of the SmartSat CRC Queensland Earth Observation Hub. More on that in a minute. I've held many and varied IT and geospatial roles. I cannot claim to be an Earth observation expert like others in this room, but I'm definitely an enthusiast. And I can now say that I at least am experienced in helping drive impact from Earth observation data. So yes, I have been in my career so long that we had reel-to-reel tapes before moving on to Beowulf clusters. I did get to do a storage project with CERN through ARNet, so that's me with the LHC. Got to do a project on climate change when I moved more into geospatial project on climate change in Vanuatu. And yes, not a project on Japan, but we're avid travelers as well. But back to Earth observation. So just some stats on Earth observation satellites. So there's around 2,000 satellites that have been launched between 1970 and 2024. 5,500 Earth observation satellites are planned to be launched between 2024 and 2033. There are 12,000 plus active satellites up there at the moment. The great majority of those are low Earth orbit communication satellites, Starlink and their ilk. So as you can see, there's a lot of dust up there. With Earth observation, we're definitely going through a transformative phase in which we're seeing the rapid commodification of space technology. So we're seeing like the reduced cost of launch and manufacturing, miniaturization, the build out of constellations of satellite. You don't just send up one satellite, you can send up 10. Greater advances in what can be done on board, greater advances in AI processing, and soon we'll see AI processing on board as well, better communications, better sensors, and a shift from sort of raw data capture to actual onboard analytics. So there's rapid change in there. This slide gives sort of a sense of the capabilities of some of the Earth observation satellites up there. You've got a temporal resolution going up the side there from yearly through to hourly. So where the satellite sits sort of gives an indication of how often you'll get data out of it. You've got your spatial resolution along the bottom. So you've got satellites like Landsat, which will be a 30-meter resolution. So you'll get 1 pixel will represent 30 meters in an image. You have Sentinel, which is like 10 meters. That's the European Copernicus program. And then you've got more and more commercial programs that are offering sub-meter resolution down to 25 centimeter resolution, which is pretty phenomenal when you think about it. Basically, you can see an LP record from space. I'm sure that's not quite the application for it. We also sort of, this is sort of broken up into different hyperspectral, different spectrum bands that you can see. A lot of satellites, or the older satellites, will just sort of be RGB with infrared, but now we're getting sort of up into the hyperspectral range where we can get more than 50 bands coming in, so you can use that information as a fingerprint. If you're looking at, say, a particular tree species, you can get the fingerprint of that tree species and detect it with satellite information. So it's all rapid advancements. But at the same time, there's also an ever-increasing number of pressing challenges that are a result of human activity and environmental factors. So there is industrialization and urbanization. It's a necessary evil, and they have a negative environmental impact. And so we need better tools to be able to address these types of challenges, using multifaceted approaches, making EO a valuable tool for understanding and addressing these issues and being part of the solution. If we focus in on one sector, such as agriculture, the problems to be solved are very many, and rapid uptake of EO, this potential iPhone moment that we're seeing in Earth observation, is timely in terms of the utilization and benefits that Earth observation can produce. So in areas like food production, supporting the increase in crop production, greenhouse gases supporting the reduction and sustainability of industries, water availability, helping Australians to manage what we know is one of the most precious of resources. So there's lots of large-scale applications for the use of Earth observation just in agriculture alone. So this speaks to the economic value. There's multiple reports available. There was a Deloitte's Access Economics report from 2021 stating that the economic benefits that EO would bring to the Australian economy would be 2.5 billion were 2.5 billion in 2020. The World Economic Forum put out a report identifying that Earth observation could add 703 billion to the global economy, whilst eliminating 2 gigatons of greenhouse gas emissions in 2030. These numbers are modeled. They're to be taken with a sort of a decent amount of skepticism. But I guess one of the key things about this is that it's clear that Earth observation does bring economic value, but it doesn't bring it without support. So, and this is sort of important for me with the Earth Observation Hub. So that line down the bottom, growth in Australia relies on increased collaboration and uptake of Australia's Earth observation capabilities, as well as bringing cutting-edge research capabilities to work closer and more strategically with the Earth observation. So what makes Earth observation so special in Queensland? So Queensland's great because it's the size of Europe, so that it's an environment in which we can develop a lot of tools and technologies. It's very rich in diverse environments. So it's not like boring old Western Australia where it's just desert and a couple of trees. Queensland's great. There are significant end user sectors, including obviously agriculture, the resources industry, the environment, or natural resource management industry, as well as we have very pressing problems. We are the most prone to disasters, so we need a lot more capability around disaster response and disaster resilience. We have a great number or a great diversity of skill sets that are coming to Earth observation, and we do have a great innovation ecosystem that brings innovators and leaders with energy and passion into the Earth observation scene. Although I was a little bit dismayed to see there is a world sort of innovation ranking, and Queensland had always been in the top 100, and we just fell out. So in terms of sort of how we view innovation, how we invest into innovation. So we have to get back up there. There are a significant number of government programs, such as the CIS program that is run by John, and an increasing number of businesses that exist in Queensland or are wanting to set up shop here. And it has a strong and growing sense of community as well. This image in the background, I don't know if anybody could hazard a guess. The orientation might help a little bit. I figured you're geographers, so you'd sort of be wanting to have a guess. Yeah, so this is a gulf. Actually, this is just near Burketown. I don't think Burketown's actually on it, but this is a false image image. And with the, so when you get a satellite image, you get them in their separate bands, and you can mix the bands to create different colored images. And the reason I like this is, and for you at home, is the line along here and along the rivers is this bright green color, and that shows the mangroves that are growing there. So it's very good for mangrove detection. All right, so Queensland's Earth Observation Ecosystem. So I said there's lots of businesses here, there's lots of research and development. All of the universities in Queensland are active in research and development in Earth observation, perhaps with the exception of Bond University. I know that ACU is active in it. There are lots of SMEs, so this integrators that I've got in the central circle. These are all the SMEs that are Earth observation companies in some form or other. Some of them you've heard from before, such as Ausius and SIBO Labs and Fugro. So they're the ones that are essentially sort of taking the data and converting it into intelligence for those end users. So those end users are government, agriculture and ag tech, mining, METs, emergency services, construction, defence, education and environment. Then below that, you've got platforms. So platforms is a bit of a catch-all in terms of the data managers and data providers. So you've got like Geoscience Australia, which has the Digital Earth Australia platform, which you can access Sentinel data through. But then you've also got commercial data providers. So these are the people who fly the satellites, the commercial satellites like Black Sky, Maxar. I think I heard that Maxar changed their name or got bought out, Planet, etc. And then you've got like plain sort of, well, your cloud providers like AWS and Microsoft. So this sort of gives you an idea. This is all exists in Queensland and gives you an idea of the scale of the ecosystem. Any guess?
Somewhere in the reef.
Somewhere in the reef. It's off Mackay. And once again, it's sort of a colorized image. And I picked up on that one because there's an Earth observation researcher, was at James Cook University, called Karen Joyce. Some people may have heard that name before, and she said that's her favorite sort of image of Earth observation image in Queensland. Her out and out favorite was Western Australia. Okay, so finally we get to the Queensland Earth Observation Hub. So the hub is a jointly funded initiative of the SmartSat Cooperative Research Centre and the Queensland Government through the Department of State Development, Infrastructure and Planning. It was originally initiated by the University of Queensland, and a big shout out to Professor Stuart Finn for the effort that he put into getting this off the ground. It really is there to accelerate the growth of Queensland's Earth observation industry through research, industry collaboration and commercialisation, and generate opportunities across the Queensland Earth observation ecosystem. Oh, I just threw that one in because I had a similar picture before, but this is a cool picture because this shows the Channel Country. You can see near Windora up the top, and I've sort of brought the two photos together. It's similar to a photo that an image that NASA was offering, and showing sort of, March 5th dry as, and then March 29th completely flooded. All right, so my journey with the hub truly began in July, I think, 2023. No, maybe it was earlier than that. Anyway, I had the privilege of working with Andrew Beveridge from SmartSat CRC, Roshni Sharma, who was with us at Frontier SI, and Terry Fremantle from NGIS. And we worked on what was called the Queensland Market Study. We basically engaged with key Earth observation and industry leaders across the state in order to identify what they saw as being the opportunities and challenges that are facing Earth observation in Queensland. We also hosted the Hub's first workshop to sort of get feedback on the report, and produce, yes, that foundational report that helped define the direction of the Hub. Then when Frontier SI was also contracted by SmartSat to appoint a Hub coordinator, I was very excited to take on the role. It's been a really rewarding opportunity to help shape the Hub's growth and strengthen connections across Queensland's Earth observation community. All right. That text was meant to turn up later, but anyway, there were sort of priorities that came out of the market analysis, and I can't read them all out at the moment. Sort of it ranged from data accessibility and open data initiatives through to education and training, and then down into, like, sector awareness and outreach, national and international engagement, and policy and regulatory support, showcasing success stories and investment in EO infrastructure. The key thing, though, that came out was this thing that the industry and research and government alike were desiring more opportunities for partnerships and collaboration. You've probably heard this in other industries, but Queensland doesn't really have, or Australia doesn't really have, the scale that we can do. We can have these mega companies that really go for it. We work much better when we collaborate and work together. And so it sort of came through in that report that people were very keen to understand more about who else was out there and have more connection with them. Bingo. Lake Catharaba, Lake Kirrabah, Wellington, Noosa National Park, Sunshine Beach, Lake Weaver down the bottom. All right, so with that theme of sort of building partnerships and collaborations, a key focus of the Hub out of that market study was to develop an active community that drives that collaboration and capacity building through events, which there have been several. We've run workshops, we've run social events, we've done sponsorship for events, and had booths at the major Australian Earth Observation event, the Advancing Earth Observation Forum, that was held in Adelaide last year, as well as additional speaking and promotional engagements. So fortunately, it came with a bit of a budget for these events. So as you can see, that we've run quite a few of them, and one of the key events that we've run, and you'll see sort of the critical minerals, the agriculture and the environment workshop. These are workshops where we really focus on bringing researchers together with the practitioners, so the SMEs that can provide the services, the data analytics, but also with the end users. In the case of the agricultural workshop, it was with farmers and ag tech and government, or those who are working in those sort of government bodies within agriculture. So it was really important to try to bring everybody into the room and have the end users articulate what problems they're trying to solve, and then get the researchers and the integrators to work together to come up with solutions. Some of those solutions would turn into project proposals, more often than not, something else would happen as a result of those meetings. That other collaborations would start. There was one at the critical minerals workshop that Queensland government, the Department of Natural Resources and Mining, got together with QUT to talk about the use of AI for interrogating all of their mining reports. It wasn't quite an Earth observation activity, but I think they had a bit of an agenda. And then 2 years later, they actually built the AI platform that they'd been talking about at that workshop. So that was a good outcome. Sorry?
Mount Warning.
Mount Warning, yes, Wollumben. So you can see Coolangatta with the sandpipe up the top corner, Springbrook, Lamington, Wollumben, Wollumbar. So I just have always been fascinated by the fact that this is just basically a massive caldera of a volcano. And Annie Nguyen once gave a talk about the biosphere that exists within that. It's really fascinating stuff. All right, so not only did we have budget for events and drinks, but we also have a hub funding program. So we ran it as 3 separate streams. We ran a partnering program, a mobility scheme, and calibration validation program. So partnering program was sort of the main program that researchers could collaborate with industry to develop something. The idea was that it would be industry led, so industry had to have the need, the requirement, and researchers had to have something mature to bring to it. It couldn't be blue sky research. It had to be something that like, you know, was sitting on their bench ready to go, whether it was like new models or software platforms. The hub would contribute $200,000 to if industry contributed $100,000 to a total of $300,000. And generally they'll run for about a year. Mobility scheme was like a bit like an internship. So it supported research to industry and industry to research placements. So a researcher could work with industry for 6 months and we'll pay their salary for that period. Or vice versa, an industry person could work in a research group. Although the take-up on the mobility scheme wasn't as great as we hoped it would be, and we never actually got to see any of that industry to research placement. And then calibration validation projects. So these are more data-oriented. So with Earth observation, it's very important to be able to not only calibrate but validate your data. So calibrate where you're looking down on a spot, knowing exactly where that spot is in terms of your geospatial measurements, and then validation. So validation going into the field and validating what the satellite is seeing. So like a field study to go into a forest and measure the density of the trees, so that you can correlate that with what the satellites are seeing. So we put 2.5 million into these programs. It resulted in sort of an $8 million pot when companies put in their own money and put in their own in-kind. So sort of $8 million in indirect activity. There are sort of, you know, ways to figure out the economic impact, but I've left that off for the moment. Queensland Treasury looked at my modelling and said, no, you got to do that again. So I'll just like, you know, say 8 million is fine. So we funded 19 projects overall, 31 project partners. I won't expect anybody to know where this is. If anybody wants to have a guess, they can. But
The Northern Mining Project.
yeah, so that's the Collinsville coal mine down the bottom. But it's more interesting that you can see the solar farms. So that's, you know, and they really show up in these colors. And I think it's a great image of progress. because it's solar versus coal. Okay, so I'll highlight a few of the funded projects. So the first one, coast. So this project was addressing the dynamics of Queensland coastlines. Now, it was the lead researcher was Dr. Javier Leon, and he has talked about this project as well as his broader work when he spoke here. Noted it back in April 2023. So it was a collaboration between Noosa Council as the industry lead, EOMAP, which is a German-based marine mapping company. They've just been taken over by Fugro, but they've got a strong presence here in Queensland. University of Sunshine Coast and University of Queensland. And the goal was to track change in dynamic coastal environments over time using a combination of satellite, drone, and LiDAR data. This one, we're hoping that Queensland government will push out a bit of a press release on this project because during Tropical Cyclone Alfred, this coast platform provided Noosa Shire Council with a range of tools and information and impact predictions that help them to sort of make informed decision making and resource prioritization during what was a very rapidly changing disaster event. So as we know, it swept away the beaches, but it then sort of gave them enough information to understand where they should try to fix things, where they should try to let nature take its course, etc. This is actually two projects that's been led by the city of Gold Coast. So, and as you can see, they led quite a large cast of both researchers and local government areas in southeast Queensland. So the first one there, satellite data calibration for vegetation condition assessment. So they're using what's called synthetic aperture radar, so radar imaging rather than optical imaging, as well as optical imaging for assessing vegetation conditions. So they have to manage very large natural areas. They want to sort of figure out how to do this without having to leave the office. So monitor it for restoration purposes, carbon accounting, and fire risk assessments. This was led by Jean-Marc Hero. It would be great if we could get Jean-Marc to talk here sometime. I'm sure he'd be very entertaining. He could at least tell some stories about how many ticks they got covered with when they went out and did those field surveys, those calibration and validation studies. Then the next project, natural resource management tools for managing targeted invasive plants in southern Queensland. And this is a great one. It's really sort of pushing the envelope in terms of being able to use satellite data to look for infestations of what is it? Cat's claw. That creeping vine. What's the other one that I really hate? The undergrowth one. Lantana, yeah, exactly. So, and typically, like they're hard to spot with sort of more traditional Earth observation data. But this M here is an image that was captured by a company called Pixel, and it was sort of their first effort at using I think it's either a 30 centimeter or 50 centimeter resolution satellite imaging platform. So it's really sort of using the latest and greatest tools to see what can be done. Smart Coast. So this is led by Fugro. We had Paul Seaton here August last year, to talk about the blue carbon economy. So this is part of that. So it's building up digital twins of coastal ecosystems, and their focus was on mangrove growth in the Torres Strait, using sort of a combination of satellite data and LiDAR data, which is your light inferred data. So it's light inferred point data. Then we've funded them for a second phase to take that information and that platform that they've developed and start to understand what the net ecosystem value is. So putting a value on the protection of these types of environments, so that it can start to become an investment tool for governments, wanting to do ESG and not just sort of, doing it in a band-aid way, but actually sort of being able to monitor the ecosystems that they're supporting and the value of them. Ground disturbance detection using very high satellite imagery. So this was one of the mobility projects where Dr. Amin Aga Khan, I think that's his surname. Sorry, Amin, if you're listening. Worked with GeoImage, a leading Brisbane-based Earth observation company, using very high-resolution satellite imagery to detect land disturbance from mining and construction. We funded other similar projects, and you can do this to a degree with machine learning, just being sort of comparing images and looking for changes. But Armin brought to this a more advanced machine learning and physics-based model. So it was much better at the prediction. It required less training data to sort of identify when there was a meaningful change. So it's enabling faster, more accurate monitoring of mining sites without having to sort of do costly field inspections. Supports environmental compliance and rehabilitation planning for the resources industries. And this might be the last one. I don't have too many of these projects to count through, but GeoNadir is a company, Cairns-based company led by Dr. Karen Joyce, formerly of JCU, and her husband, Paul Mead. And in Paul's words, they want to be the Canva of drone data analytics. So they're building out a platform that you can load your drone data in and you can get information back out. Like if you're looking at spectra, like forest conditions, coral conditions, things like that. So we have funded them for 3 projects. One, to build a national pipeline to process and share drone data, linking it with field observations, linking field observations that have been carried out by the Terrestrial Ecosystem Research Network, TERN, with satellite imagery. Next project was validating satellite accuracy using drone data. So with drone data, you can look at you can in an image you can identify features in the image, tag them, and then look at the same area with satellite data and say, okay, the drone data tells us that this is a rock, this is a piece of coral, this is a turtle, etc. But their latest one is integrated AI-driven scaling to fuse drone and satellite data together. So it's sort of allowing that automated scaling to go from, this is what we see with a drone image, and this is what we now see in a satellite image, and to be able to use that intelligence together. And this has been sort of their most significant step forward so far. And if you look them up on LinkedIn, you'll see lots of posts about this. How am I going for time, by the way? Good, okay. Oh, this is the last one. Right, so this project is between Desert Channel Queensland and Dr. Maddie Rezegi of the University of Southern Queensland, and it's developing a platform to once again integrate satellite data with ground data for Queensland's arid rangelands. So the objective here is to provide near real-time insights on pasture conditions, water availability, and drought stress. Helps graziers plan grazing and manage feed and water more effectively during dry periods. It's interesting that one of the key things that they do want to find is that greening moment in an arid rangeland, because things will grow, but being able to detect exactly when it is, or being able to get enough information to predict exactly when it is really important to graziers to understand how to move their stock around. And it's a great project, demonstrates how Earth observation supports resilience and productivity in very remote regional industries. So that was all of them. But also I mentioned the 31 project partners. So across the 19 projects. So this just sort of gives you an indication of the scale of the work that's been done. Oh, any guesses for this one? It's the veggie growing region. So it's Lockyer Valley. I don't think I tagged it. No, I didn't. Okay. All right. So that's the basically it about the hub, with the exception that the hub is nearing its completion. So there's storm clouds on the horizon. So an interesting thing, when I was gathering these images, I went to the NASA Earth Data Search site, and you can't really read it in the top left-hand corner, but I'll read it out for you. And it says that due to the lapse in federal government funding, NASA is not updating this website. So like, and then down here, there's an RFI published by NASA to look to commercial options for the next Landsat program and to explore the commercial viability. So a program that has been free for 50 years, I think, they're now sort of saying, well, how can we start charging people for this? Then also there's sites run by the US that just contain troves of environmental data, and they've all been switched off and archived. And like just sort of closer to home, Earth Observation Australia and University of Queensland and Symbios produced a report. This was March 2024, detailing the risks of continuity of data supply. Like we have so many industries, resources, agriculture, disaster management that are dependent upon this data supply, and it's a risky thing. So we did see it coming. It is detailed then in the report. So we've got challenges to data continuity, the potential Landsat commercialization and ending of data services. But overall, we have a heavy reliance on foreign-owned satellites for critical environmental, agricultural, and disaster data. Without sovereign capability, Australia is reactive and rather than resilient. And when there is a debate going on in the space sector about sovereign capability, and Australia needs to invest into its own satellites. And I'm an advocate for that, but I'm also more an advocate just for sovereign data. A lot of we get this data from the US and EU, and that's great. We house it on our own servers, but a lot of the commercial data providers, they don't sell you the data, they license it to you, and they license it to you under very specific conditions. So you have to state what you're going to do with that data, and you can't use it for something else. And so that means that you can't repurpose the data. If you're looking at environmental data to look at forest health, you can't then sort of repurpose it for looking at soil moisture. This may be a trivial example. Don't quote me specifically on that one, but that's just sort of how it can work. And so the risk will increase if we purchase these types of products and the access gets more restricted. So without sovereign capability, not just in satellites, but in that data ownership that I'm talking about, we become a price taker. We sort of, we're having to take whatever price they give us in the global EO market. reactive, not resilient. This was a cool image. It's not actually night lights. It's a combination of night lights and bushfires. So because there aren't that many cities in the dark interior. But yeah, that's composite visible infrared imaging radiometer suite on the Suomi NPP satellite. So this is once again I think a special mission run by NASA. So where to from here? And this is the question for the hub. So I said that that our funding is coming to an end, but I don't want it to come to an end. Not for my purposes. I'm quite happy to pass it on to someone else. But I think we have momentum, we have capacity, and we have capability, and we can continue to be that bridge between research, industry, and government, driving real world impact from space derived insights. But we can also start to really focus in on sovereign data capability, regional engagement, and flagship projects. So really try to build out more significant activity around data sets that we're comfortable that we can use in perpetuity. For sure, we'll also want to nurture skills, partnerships, and that innovation ecosystem to help build Australia's Earth observation independence and capacity, and reinforce Earth observation as an evolving geography tool, not just as a technology. So it is very much, geography is very much at the heart of Earth observation. It's about interpreting landscapes, change, and human environment interactions. And this image is Moreton Island from Saturday. And you can see the fire scar, and you can see the fire line. So that's a shortwave infrared image taken from Sentinel. So once again, it really shows the what you can see, what the utility is of these types of.
Where the campfire was.
Yeah, you can see the four-wheel drive driving away from it. Just a plug if you want to get on the tools and play. The Copernicus browser is great. You can specify like an area of interest. It'll sort of show you what satellite imagery is available for that. You can look through time. You can adjust your cloud cover levels, and you can look at different colors for the images as well. So I thought I'd chuck that up there if you want to sort of get on and create your own imagery, because some of it's really cool. And then yeah, stay curious and stay involved. Thank you.
The north of Fraser.
Yes. Oh, actually, I'll tell you about that one because that is one of my favorite images as well. That's the sand dropping off into off the continental shelf. So I did study with Daniel Harris at UQ, and he showed us this, and basically it was about coastal processes and understanding that sort of sand all comes out as silt from the rivers and then sort of gets pushed up, and it was all about how the beaches get replenished after storms, etc., till it gets to the tip of Fraser, and then it just drops off and it's gone. So that's why the like further north it's not as sandy. And that's a great time lapse showing that.
Do we have any questions for Gavin from the floor or from those of you online? Down the front.
Are there emerging alternative suppliers of satellite data from non-US sources?
Yes. Like the main other supplier is Sentinel. So that's the EU Copernicus program, and that's free as well. The thing is, like, different programs offer sort of, different capabilities as well. So it will be a loss to if Landsat does disappear. Excuse me. There are programs, and I talked about data sovereignty. There is a South Korean company that has launched a fleet of satellites, and they're offering a deal that we can just buy the data directly, rather than having to license it. So we buy the data. So whenever it's over Australia and imaging Australia, we get access to that. So GeoImage is one of the companies I mentioned are trying to sort of convince Australian government or someone that this is a good deal and something that we should be considering. But there's also a lot of companies that don't even necessarily give you the data in the first place. They'll give you the outcome. So they've got their own satellites and they'll give you the analytics. Not a terrible model. And it's more directed, sort of, it will be directed towards agriculture, for example. So there's a Canadian company called Earth Daily that's following that model, and they're about to launch a fleet of 9 satellites, I think. The thing is, the thing that strikes me, we have companies like Planet and Maxar, and they're great companies, don't get me wrong. But they're very underutilized, and they're flying over, like, these satellites are flying over Australia, and they're imaging everything. Sometimes they switch them off. But it strikes me as a wasted resource, and that surely there could be deals that we could do with these types of companies to get sort of more sovereign access. I know that's also a question for John, because John sort of works in that environment much more than I do. But I won't put him on the spot.
Thanks for that, Gavin. Any other questions from those on the floor or those online?
You mentioned that Australia needs to develop its own sovereign capability. In terms of hardware, how many satellites would we really need?
Look, I'm a bit of an advocate for that, and I'm more an advocate for that data sovereignty, that we get to own whatever data we can access. In terms of satellite capability, it would be hard to get to that level of what the EU and NASA and the US are doing. But you would certainly prioritize. You'd certainly be looking at what your most important use cases are. I would say that fire management would be a very important use case. So you'd be looking at what you could do to provide that. But that can be difficult. It's in order to monitor a fire constantly, it has to be a geostationary orbit, which means it has to be further out, so it can't see with as high a resolution, or you have to fly more satellites to get more coverage, which costs a lot more money. Or you look at other solutions. CSIRO have been collaborating with a company called Stratoship, so Queensland company, great little startup. They're building balloons, dirigibles that will float in the stratosphere and have fire detecting cameras on them. So there's those sorts of Australian style options as well.
Question over here.
This might be difficult to answer in general, but when you do your ground survey validation of remote information, what sorts of reliability percentages do you get?
I'll have to take that specific question on notice.
think it probably depends on exactly what you're looking at.
Yeah, yeah. I don't know. You got a thought on that one?
Yeah, ultimately it's a factor of what you're comparing to and what the resolution was,
Yeah.
and what the model is that you're comparing against. Because if you're doing general sampling and you're comparing to like a sentinel pixel of 10 by 10 meters, you're getting a lot of generalization in that anyway.
Yeah.
If you're comparing to a 30 centimeter data set in dense rainforest canopy where you can't see the ground, a bit more complex.
Yeah, the reason I asked is because while we were in Hawaii, we were told about a project where they're identifying coconut trees which are under attack from a particular insect.
Yeah.
And so they were trying to detect individual coconut trees within fairly dense foliage.
Yeah.
And it makes sense to be able to have a fairly high reliability rate, because then you can actually attack the insect on particular trees.
Yeah.
So
Yeah.
I was wondering what the
It's still a difficult question to answer. I would say it would be very case by case, because you're also, as John said, like, there's different models. So you're trying to use these different modeling tools to say, yeah, that's a coconut tree under attack sort of thing. So it can heavily depend upon those as well.
An example in the Queensland context, this was pre-COVID actually. A group out of the Environment Department won the H1, whatever the
Bird flu?
the banana
Okay.
bacterium was going through North Queensland. They took 80 centimeter satellite imagery and 20 centimeter aerial photography and ran at then cutting edge machine learning models against it. And they were seeing about 80 to 90% accuracy in detecting individual banana trees, both on properties, but also in forest and in other vegetation. And really that came down to the morphology of the banana leaf was quite different to other species. So it was easy to dissegment. If we were trying to figure out a specific species of eucalypt in a eucalypt forest, that one's going to be a much trickier challenge and likely lower accuracies, unless you had the right bands of hyperspectral satellite data to pull out that specific species. Cool.
AI is the buzzword at present.
Absolutely.
Are you actually seeing that? And is there real progress being made to assist the sort of work you're doing coming from that domain?
Yes, absolutely. And it's more machine learning and deep learning. So you're dealing with images. When a lot of people are talking about AI, they're thinking of generative AI like ChatGPT and its ability to assimilate text and make sense of text. So in this case, you're more working with imagery. There have been huge advances in how we can analyze the contents of an image and basically train a model, as said before, to train it on detecting a particular species or a particular feature. So it can start to find that in the case of the mining project where they were looking for land disturbance, and so they did some training of the model with, like, here's undisturbed land, here's disturbed land, but they were also using more advanced physics in the models for it to say, there is a change here, you better sort of, figure out what this change is. So there is a lot of that. We are starting to see what's called multimodal AI platforms as well, which can sort of combine this image analysis capability with text analysis capability with tabulated data, like measurement analysis capability. So there's a couple of sort of big platforms out there. I know that some of the researchers here in Australia are wanting to set up similar types of platforms. So you can basically load up your satellite data and your environment data and start to make sense of the two together.
Gavin, you talked about the EO hub, the Earth Observation Hub, being looking for its funding, I guess, which is typical of these sorts of enterprises. Just for purely selfish reasons, will Earth Observation Australia, the sort of professional gathering of people, survive?
EOA will will survive. They did get some sponsorship from Geoscience Australia to support their activities. So they were starting to expand their activities, but that sponsorship was only for a short period of time. So they've gone back to being a membership-based organization. So the hub works a lot with EOA, and we co-promote things. It is more, or it typically sort of does focus on more individual type of activities. It's more a member type organization rather than what the hub is. But also they run a lot of webinars around careers and things like that. So I think it's got its place. It will do great things. It will run the conferences. It will produce reports, etc. But like with the hub, it needs that extra funding boost to make meaningful change. And I am looking for that extra funding boost from Queensland government as we speak. So watch this space.
My question for you is, throughout the hub, were there any projects you wish had happened but didn't for one reason or another? Your favorite project that never saw the light of day? Potentially to inspire someone into the future.
That is a great question. We did get an application from Strataship for funding to support their next launch, and we had to knock it back for, well, typically we would get 2 to 3 times as many applications as we could fund in a particular round. We never knocked them back, so to speak. Would prioritize, and unfortunately, like that particular project didn't make the cut. But I just, I think I got to go out to the ARM Hub, the Advanced Robotic Manufacturing Hub, on a tour one day, and I met Daniel Fields, the CEO of Strataship, and he was there taping up his balloon, and like it's this massive thing. It's bigger than the floor of this building, and he's like, and it looks like a goon bag, like a wine bag, and he's just there patiently taping it up, like getting ready for the next launch. And I think that's a really great Queensland story. We could launch our own satellites, but and we do have some of our own satellites. So SmartSat was involved in the launch of the Canyini satellite, which funded by South Australian government, and was effectively a demonstrator of what could be done with launching a CubeSat. So we have that capacity and capability. Say it's a bit fragmented at the moment. Maybe we will see it coalesce over the next few years into a viable program. I don't know. I have to watch this space.
You did mention the word that I was reluctant to raise, Chinese supplied data. Is that increasingly available?
Yep. Typically.
Can you still buy it?
Yeah.
Okay.
For now, at least.
But not for defence purposes.
Typically not.
No.
I'm sure that you could. They'd be happy to take the picture for you. Yeah. And that comes back to sovereign risk.
Yeah.
That's right.
Which countries can we do deals with? What's the exchange rate? Are their governments willing to sell it to us?
All right. Thank you.
Cool. Well, everyone, thank you so much. That brings an end to our presentation. Thank you. Absolutely.